Hi students, today I will discuss one more new topic, that is kinetic theory of gases. This chapter is very important. Compulsory you can expect the question in the NEET and JEE-MAIN. No? Why? Because gaseous states is removed from the chemistry. So if they want to ask related to the gas, no compulsory, they will choose only kinetic theory of gases. So generally speaking, no, suppose in mechanics what we studied now, suppose one ball is there. So if you are throwing, so therefore we know that mass of the ball. Therefore while it is moving, the mass of the ball will not change. So therefore we will calculate kinetic energy of the ball is nothing but a half mv square. Clear? So therefore, okay, these all are like a rigid bodies, no? Therefore we can calculate whatever the things mechanics, we studied, no? Therefore it's not an issue because a fixed rigid mass it is there, no? But when you are dealing with a fluids like gases and liquids, suppose a river is flowing. Therefore, how much amount of kinetic energy is there in the river, no? Therefore we cannot calculate the mass, particular mass. So similarly, a wind is flowing, no? So therefore, how much amount of mass of the wind or mass of the gas is flown? So we don't know. Therefore, so like that we cannot calculate the kinetic energy half mv square, right? So I'll tell you one simple rules, no? So whenever you are dealing with the gases, you have to follow these conditions compulsory. What are the conditions now? First one, because we don't know the particular mass of this one, no? So therefore, this whenever you are dealing with the gases, always use the mass in terms of density. You know density formula, density is nothing but a mass by volume. So therefore, mass of the gas or it will be equal to density into volume. So whenever this is density into volume. Whenever you are dealing with the gases or fluids, so definitely a mass should be replaced with a density and amount of volume. Like this, we can calculate the mass. And also, second important, okay, we got the mass, no? Second important. Therefore, so if you are calculating, so the temperature especially for the gases, not the fluids, no? So, I mean, not the liquids, no? So, especially for the gases, no? So, use always temperature in kelvins. So, temperature in always in kelvins. Kelvins only, don't use degree centigrade, don't use Fahrenheit scale. So, don't use any other scale, only use the Kelvin scale like absolute scale, absolute temperature. You know how to convert it and all this one, no? So, we already did in a thermometry one video. So, try to observe about this Kelvin scale. Okay. So, also we will discuss why we have to use only Kelvin. So, that we will discuss now. And also, suppose if you want to find how much amount of gas is there in the cylinder. One cylinder is there, like for doctors, no, they require oxygen cylinder onto this one, no. So therefore, in a cylinder, how much gas is present? So how to calculate it now? See, therefore, gases, no, very biggest problem is it does not have any fixed volume. For liquids, so definitely there is a fixed volume will be there. 1 liter of water means 1 liter of water only. It will occupy only 1 liter space. But 1 liter of the gas, it can occupy this much big room also. Even it can occupy very small amount of space because exerting the pressure and lesser pressure, no, volume will be larger. So therefore, fixed volume is not there, no. So how much amount of gas is there or what are the measurable properties? See, whenever you are dealing with the gases, no, in a cylinder, so what you have to observe, what are the thing you have to measure it, so that you will understand how much amount of gas is present in that one, no. So that all are measurable properties of gases. Measurable properties of gases. What are the measurable properties of the gases now? First one is volume, because volume changes by changing the pressure. Also next one is pressure, and also third one is temperature. These are compulsory, these values should know. And fourth one is therefore number of moles of gas, right? Number of moles of a gas, we should know it. These are the 4 measurable properties. Then you will understand complete detail about the gases, how much gas is present. So you should know what should be the volume of the cylinder, at what pressure it is filled onto this one now, at what temperature is filled, how many number of moles of the gas it is filled. So like that, so in it we should know all these three parameters, then only you'll know about the gases. Some basic things no we'll study. So what are the units we'll use it no. So volume is simple thing no, you know it. What is a SI unit now? Volume is nothing but amount of space occupied onto this one no. You know what is a unit? SI unit is what is a SI unit? SI unit is nothing but a meter cube. Sometimes we will measure in terms of liters also. Therefore 1 meter cube, you should know the conversions, that is nothing but a 1000 liters. So 1 meter cube is equals to 1000 liters. Therefore here 1 liter is equals to, so 1 liter is equals to 10 to the power of minus 3 meter cube. Clear? So even in terms of sometimes cc, centimeter cube, they will give no 1 meter cube. 1 meter means 100 cc. So 100 centimeter. So 100 centimeter, 100 centimeter. Like that, 10 to the power of 6 centimeter cube. That is cubic centimeter. Like that. Right? Now, next one. 1. So cc, you can write down like a 1 ml onto this. Or 1 liter, so it will be equal to 1000 so ml. So therefore here we can rewrite it as all these units now. Clear? So right. So 1 liter is equals to 1000 milliliter or 1000 cc also we can rewrite it as now. Therefore here, so 1000 cc, 1 liter is equals to. Clear? These are the slight conversions. So in terms of liters and meter cube. And next one about the pressure. We already studied, we will study in pressure in the mechanical properties of fluids no very detailedly. So just units no, you should write, you should know it no. So pressure, what is the formula? Force per unit area, and force exerted by the liquid is nothing but a rho gh, like that no. So now what is a unit now? So unit is nothing but a Newton per meter square, SI unit no. So that is nothing but a Pascal. Pascal is the SI unit of pressure. But pressure exerted by the gas no will measure in so many different parameters no. That is 1 atmospheric pressure. 1 atmospheric pressure, so we can rewrite it as 1 atmospheric pressure is nothing but a 1.01 into 10 to the power of 5 Pascal. See, atmospheric pressure is given, don't use atmospheric pressure, always stick on to SI unit now. And there will be one more unit is there, 1 bar. So it will be equal to 10 to the power of 5 Pascal. So 1 tar it will be there no. Therefore 133 Pascal. So still some more units also is there. So 1 atmospheric pressure, we know it no, 1 atmospheric pressure 76 centimeters of Hg. Or so therefore 10 meters of water also will be equal to 1 atmospheric pressure. So these all are the some units we will use it in this kinetic theory of gases. You should be aware of all these one no. So conversions at least. So different sometimes they will give 76 centimeters of Hg means, again you will not confuse. So it is 1 atmospheric pressure, and also 1 atmospheric pressure should not use it, you should use only Pascal. Always stick on to the Pascal. And also about the temperature no. So you know temperature should be measured in compulsory kelvins. So Celsius and Fahrenheit no, how to convert it already I taught in the thermometry, please check it out. So right, number of moles, how to calculate the number of moles now? So number of moles of a gas. So how to calculate now number of moles of a gas? It will be equal to mass of the gas. That means amount of mass of the gas by gram molecular weight of the gas now. That is, so therefore gram molecular weight of gas. Therefore these are the number of moles, you can calculate it now. Clear? So these are the basics related to the gas now. Completely basics, compulsory. So these all are the things no, compulsory, you should know it, 100% sure, right? So now we will go for how this here. So for the gases no, how this volume is changing the pressure, and how the pressure is related to the temperature, volume, temperature, number of moles, and all this one no, we will relate it. That is like related to the basic laws related to the gas now. So first one is you might have studied in 9th class. So that is Boyle's law. Boyle's law. What is the statement of the Boyle's law? Most of the students, they will tell that pressure is inversely proportional to the volume, but they will not tell one more condition. This is what? So for whenever you are having any relation onto this one, these conditions are compulsory for a given mass of a gas. For a given mass of a gas, that means mass of the gas should not change. Given mass of a gas, that means number of moles of a gas, it will be constant. So we are showing the relation between pressure and volume now. So we have to take the temperature also should be constant. Temperature also should be constant. Therefore, if number of moles of a gas is constant and temperature is constant, no, then the pressure is inversely proportional to the volume. So pressure is inversely proportional to the volume. That means if you compress the pressure, compress the gas, what will happen now? Compress the pressure, compress the gas means you are exerting the pressure. So when you are exerting the pressure, what will happen? The volume will decrease, obviously. So volume will become smaller of this one. Therefore, we can compress the gas, no? So pressure increases, volume decreases. Therefore, pressure decreases, volume increases, no? But number of gas molecules, no? Number of moles, no? It should be constant. See some simple example. Sometimes, suppose if you are filling the air in our car tires, so our bike tires, what will happen now? When you are filling the air into this one, no? So the tire will get bulged. That means volume is increasing. The pressure inside the tire is also increasing. Their pressure is directly proportional to the volume. Is it the Boyle's law or not? No, is it not a Boyle's law? Why? Pressure is directly proportional to volume. How? We are seeing no. But their number of moles of a gas is not constant because we are continuously filling the air in the tire onto this one. No? Therefore, that's why pressure is directly proportional to volume in that situation, no? Where number of moles is not constant. It is not a Boyle's law. Even temperature constant means what you can write it now? This is called isothermal process. Isothermal process. Remember that isothermal process, temperature throughout this one is constant. So that means we should not make to increase the temperature, we should not make to decrease the temperature. So see, suppose suddenly if you are compressing, no, definitely there is a change in temperature will take place, no. So we should not make it to change the temperature. That's why isothermal process are said to be like a slow process, because we have to compress it slowly and expand it very, very slowly, so that temperature should not change onto this one. That's why this Boyle's law is a slow process now. Now we can rewrite it as, so pressure into volume is equals to constant. So therefore we can rewrite it as P1 V1 is equals to P2 V2. So a constant means is related to the temperature onto this. Now we'll draw the relations, no, the graphs related to this one. No, simple thing, it is inversely proportional graph. So therefore here pressure and this is volume. So what you can write it now? So here, so pressure into volume is nothing but this inversely proportional graph, no? So these are, we can call it as like a isotherms also. This is T1, and if we are increasing the temperature T2, so suppose if we are again increasing the temperature, therefore T3. So as your temperature is increasing, therefore pressure and volumes are getting increased. So therefore the graph, it will be shifted outward. That is nothing but T3 is greater than T2 is greater than T1. Clear? Sometimes different type of graphs also will be drawn here. No, what is the different type of graphs now? Here, so pressure into 1 by V. So 1 by V, how it will be directly proportional. If I remove this one, it will get constant onto this one. So therefore the graph, it will be just straight line. Clear? Right? So sometimes one more graph also it will be asked, no? What is this graph now? Here, therefore here PV, so with temperature, no? So what will be the graph here now? The graph, it will be, so PV, it will be constant onto this one, no? So horizontal one, no? This it will be the graph. Okay? Sometimes they may ask you, so we'll see some questions related to these graphs, no? So if two graphs are given, which one will be having higher temperature, that will discuss like a problems. This is about the Boyle's law, right? So these are the slightly relation between pressure and volume, right? But condition is what? Number of moles of a gas is constant, temperature also should be constant onto this. Similarly, so you might have studied again this law, that is nothing but a Charles law. What is Charles law now? So again the same one, same. Therefore here number of moles of a gas is constant, and this Charles law is given the relation between volume and temperature. Therefore here, so volume and temperature it is given the relation, no pressure is not given. Therefore pressure it will be constant. Pressure it will be constant. That means, so therefore here, so here pressure is constant, number of moles are constant, number of moles are given mass of a gas, no. So therefore here volume of a gas it will be directly proportional to the absolute temperature. Absolute temperature. Therefore we can rewrite it as V by T, it will be constant. So what you can write it now? Therefore V1 by T1 is equals to V2 by T2. Clear? Clear? So pressure is constant, we can call it as like a isobaric process. Isobaric process. Right? Iso means same, baric means bar is a unit of pressure. Therefore isobaric pressure onto this one. Right? Isobaric process. Now how about the graph? Okay, this is for absolute temperature. Temperature should be compulsory. I told it should be in kelvins only. So how the graph it will be? The graph for this one, no, we can rewrite it as, therefore here volume and temperature. How the graph it will be there now? Graph it will be like a straight line graph, right? At a given pressure. Therefore pressure is constant. Clear? Suppose this is in terms of absolute temperature, that means it should be measured in kelvins. Suppose if it was measured in terms of degree centigrade, how the graph it will be? Here you will understand degree centigrade, therefore here it is a volume. So even at 0 degree centigrade, so still volume will be present. That means the gas will be still, it will be present, it will be having certain amount of occupies a volume at a 0 degree centigrade. That's why the people can live at a 0 degree centigrade. That means 0 is not, people can live means their oxygen or some air it will be present. No? Air will not becomes to the 0. So here at 0 degree centigrade, no, still there will be a volume of the gas it will be present. So therefore it will be a straight line. Now at what temperature the volume of the gas, that means volume of the gas means what? So the total, this much amount of volume of this is there, no, this total gas has to be comes to the 0. Therefore when it will takes place now, so if we extend it, no, therefore if we extend it, no, so at minus 273 degrees centigrade, that is nothing but a 0 Kelvin, that is at absolute 0. So at minus 273.15, actually minus 273 degrees centigrade, at that point the total volume of the gas, that means gas it will dies, therefore total volume it will becomes and fall on the ground. Gas only will not be present at minus 273. So therefore minus 273 gas will becomes to the 0. So therefore everything will becomes to the 0. So that's why we will start from absolute scale onto this, not from Celsius scale onto this. You understand, no? So we'll study what is 0 Kelvin. So what will happen at the 0 Kelvin also we'll study in some more topics now, right? So this is about the Charles law. Also we can write down V by T. So at constant pressure we can draw the graph here, no. So these all are the some basics graphs onto this one, no? So here therefore we can write down, so V by T at a given pressure. So what will happen now? The graph it will be, it is a straight line. Is it? Because V by T is constant. Clear? Next one, pressure law. Pressure law. What is the pressure law now? So pressure law, again it will give a relation between pressure and temperature onto this one. Again for a given mass of a gas, so number of moles it will be constant. So for a given mass of a gas, number of moles, amount of gas should not change. Pressure and temperature is given now, therefore volume it will be also constant. So when volume is constant, what you can write in now? Isochoric process, right? Isochoric process. Clear? So therefore here, so therefore volume is constant, therefore pressure of a given mass of a gas is directly proportional to the again absolute temperature. again the same story. So P by T, it will be constant here now. So what you can write it now, P1 by T1 is equals to P2 by T2. Clear? So again the same graphs, everything, instead of the volume, we written here how the graph it will be there. Here pressure and temperature. Temperature should be in kelvins. If it is kelvins, therefore it will be starts from 0. So where volume is constant at V1. Clear? So again, if you are taking at 0 degree centigrade, I mean temperature in degree centigrade, so this is a pressure. So at 0 degree centigrade, still a certain amount of pressure it is going to exert, no? So pressure will not becomes to the 0, it will be 0, it will be straight line. So pressure will becomes to the 0 only at minus 273 degree centigrade. Clear? So if you are calculating at 0 Celsius scale, no, the graph it will be like this. So at this one, no, it will be like this now. Clear? So next very important concept, no, will combine all these gases, all this one, no. So that at higher temperature, somewhat a higher temperature, no, we can write it as like a ideal gas. Ideal gas. Really all the gases are ideal? No. So therefore ideal gas will be there. So ideal gas means what? Which all will obey all these rules and rules in this one, no, at all the temperatures. So what will be the ideal gas equation now? Ideal gas equation we can write it as two equations. We'll write it now. What are the two equations? No. So PV by T. Therefore actually, so PV by T or PV is equals to, we can rewrite it as, you might have studied in lower classes also, that is PV is equals to nRT. This is your ideal gas equation. Clear? So what is N? N is nothing but a number of moles. What is R? R is nothing but a universal gas constant. So T is nothing but a absolute temperature. PV, what is PV? PV will write it as like a energy. So this is energy, so it will be depends on the temperature on this one, or work done. Okay, so it is in terms of number of moles, it is universal gas constant. No, we can write down one more equation. No, so PV is equals to NKT. What is the difference between these two? Therefore here this is in terms of number of moles and universal gas constant, no, R. Here yes, N is nothing but this, PV is equals to NKT. So N is what? Number of molecules. That means in a gas, how many molecules are present? Number of molecules. So if it is a molecular gas is there, number of molecules. If it is atomic gas is there, number of atoms. What is K? K is nothing but a Boltzmann constant. Boltzmann constant. No. Therefore, here in these two cases, no, so PV by T, therefore PV by T, it will be constant. So what you can rewrite it as now, therefore P1 V1 by T1 is equals to P2 V2, right? Here P2 V2 by T2. Therefore we can write these equations, no. Then we will write down this some more things, no, related to this. What is R? R is equals to, so what you can write it now, PV by NT. Therefore this is a universal gas constant, no. So therefore what is the unit now? PV, I said, no, pressure into volume is the work done. So therefore what is the SI unit now? SI unit. What is the SI unit now? Therefore PV is nothing but a joules. So by number of moles into therefore kelvins. Clear? So joule per mole Kelvin now. Right? We can write down the dimensional formula here now. Dimensional formula joules. Joules is nothing but a M1 L2 T minus 2 by mole by Kelvin, K minus 1 mole minus 1. So this is your dimensional formula. What is its value now? R value is equals to 8.314. You can write down. So easy calculation, no? 8.314. 8.3 we will take it, no? Therefore joule per mole, therefore Kelvin now. So this is your 8.314. Now we'll write down. So the same thing for this equation now. So what is the Boltzmann constant now? Boltzmann constant we can write down. So PV by therefore NT. So PV by NT. So what you can write it now? N is nothing but a number of moles, right? Number of molecules or number of atoms. Okay. So what is the unit now? What is the SI unit? SI unit is, that is nothing but a joule per Kelvin now. Number of number is does not have any units onto this one. What is the dimensional formula for this? Dimensional formula is m1 l2 t minus 2, therefore k minus 1. Clear? So what will be this value? So this value is nothing but a Boltzmann constant 1.38 into 10 to the power of minus 23. So joule per Kelvin. Now this is Boltzmann constant onto this. Clear? Now these two I am telling you, okay, these are the some extra things, no, but these two formulas are very very important, no. So we'll use in kinetic theory of gases these two formulas maximum number of times onto this, and obviously this also same. Clear? Also we'll write down this one, no. So right, remember this. So we written now PV is equals to nRT. This is n is nothing but a number of moles. N, therefore it is n moles. PV is equals to nKT. So therefore n is number of molecules or number of atoms. If molecular gas is there, number of molecules. If it is atomic gas is there, number of atoms. So you can compare these two, therefore we can write down. So therefore nR it will be equal to nk. Clear? So this nR it will be always equal to nk. What is n now? So n we can write down. So n number of atoms, so number of molecules. So we can write down therefore n into R by k. So n, so therefore if you take it as for 1 mole, for 1 mole of the gas, so for 1 mole of the gas R value is nothing but 8.314 divided by 1.38 into 10 to the power of minus 23. So you will get it as now one thing, no, therefore 6.023 into 10 to the power of 23. What is the meaning of this one now? The meaning of this, that is nothing but a, this we can call it as like a Avogadro's number. Avogadro's number. Avogadro's number, what is the Avogadro's number now? For 1 mole of a gas, it contains, so for 1 mole of the gas, it contains this many number of, if it is molecular gas, number of molecules. If it is atomic gas means what? Like ideal gas, I mean noble gases now, that is helium gas, neon gas, therefore their number of atoms. Like oxygen gas is their number of oxygen molecule, nitrogen gas is therefore here if you substitute all this one, no, so amount of volume, right? So for at 1 mole of gas at STP, so therefore 1 mole of gas at STP, just you can substitute all this one, no, in this formula, right? So therefore you can tell that volume occupied by the gas at STP, so 1 mole of the gas at STP, it will be equal to 22.4 liters, right? 22.4 liters. No, understand? No? So therefore volume of a gas, it will occupy 22.4 liters at STP, 1 mole of a gas. Clear? So this concept also will use it. So most important concepts onto this. Okay. So and actually we did not, these are the basics for the gases. So we did not start what is kinetic theory of gases, no. So we'll do some questions on this part as like a separate video. So mostly all the numerical questions, no, all the problems, no, related to this different models, no, we'll do as a different part, no. Please first go through this one, no, then come back to the next part after this, right? So thank you. Please subscribe to my channel. No.